In this lesson, we will learn to distinguish between metals, nonmetals, and metalloids using the periodic table. Before we look at the periodic table, we want to look at the chemical symbols. These are just abbreviations for the elements. Notice that capitalization is very important. When we have a chemical symbol for an element, it always starts with a capital letter, and if it has a second letter, the second letter is always lowercase. So if we see capital C, capital O, that is actually a compound that contains both carbon and oxygen. If we see capital C, lowercase o, that's actually the element cobalt. So it's important to write carefully when you're writing the chemical symbols. The periodic table of the elements contains a lot of information stored in it, not only with the symbols and the numbers stored there, but also in the way that it's laid out. Understanding that things in the column act similarly to one another is a useful tool to have. For example, the chemistry that fluorine undergoes is similar to chlorine and bromine and iodine. Likewise, lithium, sodium, potassium, rubidium all have similar reactivities. Many of us have seen videos of what happens when sodium reacts with water. The other elements in this first column, excluding hydrogen, which we'll talk more about later, but these first column all behave very much the same. Lithium has a very mild reaction with water. Sodium has a fairly violent reaction. What do you think potassium is going to do, and rubidium? Hopefully you predicted that they would be more violent and more explosive in their reaction. So what we're going to see is that we can start to understand behaviors and predict them as well based on the periodic table. So the first thing we look at is the way the periodic table is laid out. The columns in the periodic table are referred to as groups, and the rows are referred to as periods. So we say the first row is the first period. So we'd say this is a second period elements, third, fourth, and so on. The groups is where we see the similar chemistry. Hydrogen itself is kind of an oddball. It doesn't really belong here in the first column. In some ways it belongs in column 17, but in other ways it doesn't. So it's kind of here, although it really doesn't belong anywhere. It's kind of in a group all by itself. Now we can look at how these are divided up. So on the left side of the periodic table we have metals, and on the right side of the periodic table we have nonmetals. So earlier we talked about our ionic compounds and our molecular compounds. And we can identify ionic and molecular compounds based on the elements that are inside that compound. So if I have an ionic compound, what I see is it's typically a metal plus a nonmetal. A molecular compound is two or more nonmetals. Now in this course, we're mainly going to be focused on looking at the nonmetals because we're ultimately getting into biological chemistry, and the elements over here on the right side in the nonmetal region are what make up most of the body. And in fact, the vast majority of it is carbon. We've got some nitrogen and oxygen, lots of hydrogen in there, but these four elements are the primary components. We do see other elements present in the body, and we do see some metals present as well, but the vast majority of our biological molecules are made of carbon and hydrogen with some nitrogen and oxygen mixed in. The last group we look at on the periodic table are the metalloids. So these are the elements that kind of form the border between the metals and the nonmetals. There's not a hard and fast line between a metal and a nonmetal. It's a gradual change from the left to the right. So if I look, for example, at sodium, very metallic character. Magnesium still pretty metallic. Aluminum starting to get a little less metallic. Silicon is in the metalloid region, and then phosphorus, sulfur, and chlorine. So just like in a rainbow where there's a gradual transition of colors, in the periodic table there's also a gradual transition of properties. And so these metalloids will behave a little bit differently than either the metals or nonmetals, but have some characteristics of both types of elements.